everyone, good afternoon, good evening to all my dear students and welcome back once again to Buddy Education. So before we will start our today's class, first I want to sincerely apologize to all my dear students because due to some family emergency, mathematics class has to be postponed. But don't worry student, as now I am back. So let's begin again your preparation for your term 1 examination. So students, till now we have covered your chapter number 1, number system. So till now, if you haven't watched all those classes of number system, you can go and watch out later on. And today we are going to begin with a very important chapter, polynomials, right? You must know that how important this chapter is for your grade 9, and not only for your grade 9, but later on also this is that chapter that is going to help you a lot. All right, so now without any further delay, let's begin with the chapter polynomials. All right, but before that, let me have a quick check on the sound, whether I'm audible or not. If I'm audible to all of you, if I'm properly visible to all of you, you can share a thumbs up in the chat box so that we can begin with our today's class. All right, let me have a quick check, everybody. You all have to give me a moment. All right. So I know that this break hampers a little bit of your study, but don't worry, as now I'm back. So I promise that from now onwards your classes will be continued in a regular manner, and we are going to soon cover up your syllabus of your term 1. All right, so I guess I am properly yes, I'm properly audible. Okay, so the chapter is polynomial. Let's first see that what all topics we are going to cover up in this chapter. So students, first we will understand what is polynomial, how we define the polynomial, how a polynomial is different from expression. The second topic that we are going to understand will be the value of polynomial. Then we'll be learning about how to find zeros of the polynomial, and then one of the very important concept of the chapter, remainder theorem and factor theorem. And then you can say one of the complex topic of the chapter is the identities, and by using identities you have to learn how to factorize the given polynomial. So this is all that you have to learn in this whole chapter. So pardon me because today my throat is not that well, right? So I may take little breaks in between for water. So let's start the chapter polynomials. So the first thing that we need to understand how a polynomial is different from expression. So when you have studied expression, the definition that you have learned was that for making an expression, all you have to do, you have to combine some variable along with some constant n with some mathematical operations, right? So for making an expression, all you have to do, you have to combine few variables, few numbers along with some mathematical operation. Mathematical operation means plus, minus, multiplication and division. And when you will do this, the output that you will get will be known as expression. For example, if you talk about this, if you think of any variable, right? So the variables can be written in the form of a, x, y, z, p, q, r, and so on, correct? You can think about any number, right? So we can think about the number 3, 1 by 2, minus 4, right, under root 2. It can be any number. Then think about all the mathematical operation that you use generally. So the mathematical operation that we use are plus, then minus, multiplication and division, right? Now all you have to do, you have to start combining them. How we'll combine them? Just suppose I have chosen a variable x, all right, and then I have chosen the number 1 by 2, all right. and then I have chosen the mathematical operation plus over here. Then this is whatever is formed is known as expression. Whatever is formed is known as expression, right? Now, you can also do it like that we have chosen two variable, for instance. For example, I have chosen Z, I have chosen P, right? And then I have took few numbers with them, right? I have took a number 2, I have took a number under root 2 with this, all right? And then I have chosen a mathematical operation minus over. Then whatsoever is formed again will be known as expression. Now this is the basic definition of an expression. But you can also say that, ma'am, what if you will take any power of the variable, then will it be an expression? Of course it will be. You can take it like x cube minus z raised to the power 1 by 2, and then suppose you have taken a number 4. This is also an expression, right? So the basic definition of expression is clear to all of you, that if you want to make an expression, all you have to do, you can combine any number of variable, any number of constant, and then you have to use any mathematical operation between them, and that's how we can form an expression, right? So the first definition is clear. But now the point is that, ma'am, almost the polynomial looks like this. Then what's the difference between a polynomial and expression? So polynomial is another specific, or you can say special type of expression with one little condition, and that condition is that the power of the variable should always be a whole number. If any expression holds this property, then expression will be known as polynomial. So we understood this, that all right, polynomial is nothing else but this special category of expression in which the power of the variable, please note down this point, that what I am saying, that the power of the variable, I am not talking here about the constants, I am not talking about the coefficients, right? I'm so sorry, I already mentioned that my throat is not that well today. So we understood that if we want to convert a expression into polynomial, or if we want to name an expression as polynomial, it has to follow a condition. What's that condition? That the power of the variable should only be a whole number. Means it can be 0, it can be 1, it can be 2, but can it be minus 1? No. Can it be 1 by 2? No, because all these numbers are not whole numbers. So whenever any question comes like to verify or to check whether a given expression is a polynomial or not, all you have to do, you have to check this condition. Now, in case if I write down an example for you, right? If I write down under root 2 x plus y plus 3z, right? This is the first example that I am writing. This is the first one. All right, now let's take another example too. X plus y raised to the power minus 1 by 2 plus 7z. All right, let's take one more example. Pi x plus y. All right, now we have to identify whether among these three examples, the expression will be known as polynomial or not. So let's check the first one. All right, so the condition is we have to check the powers, right? We have to check the powers of the variable. Okay? For the numbers, it does not matter whether the power is whole or not a whole number, whether it is negative or not, right? We have to only concentrate on the variable part. So we check for the first example, the power of x is 1 here, so it is good to go. The power of y is 1 here, it is also good to go. The power of z is also 1, so it is also good to go. So is there any problem in this expression if we call it as polynomial? No. And we can call this is a polynomial in how many variables? This is a polynomial in 3 variables, right? So this is certainly a polynomial. Now let's check the second example, right? In the second example, if we take the x, right, then the power is how much? 1. If we talk about y, the power is firstly negative, which is not whole, and the power is 1 by 2, which is also a rational number, right? So here the condition is not being followed. That's why it is not a polynomial. Now let's talk about the third example. Here the coefficient. Coefficient means the number that is being attached to the variable, right? So here the coefficient is 5, which is irrational. But does it matter? No, because we are only concentrating on the power of the variable. So it does not matter whatever the coefficient is, right? The coefficient can be negative, the coefficient can be rational, the coefficient can be irrational, it can be in the any form of real number, right? The only concentration should be on the power. So here the power is 1, power is 1, so it will also form a polynomial. Now which all kind of polynomial you will be talking about in your grade 9 will be the polynomial in one variable, right? So you will be generally talking about the polynomial of this kind where the variable will be only one at a time. For example, you can talk about x square minus 7x plus under root 2, right? This is a polynomial, there is no problem. You can talk about y square plus 7y or y cube. You can talk about this kind of polynomial. You can see that this is a polynomial in x, that's why we will write it as px, right? P for polynomial and x is standing for whatever variable you are using in that polynomial. Here you can't write it as px. This is absolutely wrong because the variable is not x, right? The variable is y, so you can write it as py. Now, can you also write it as qy? Can you also write it as hy? Yes, definitely you can change this. This symbol you can change. You can write it as p, q, g, x, not x, right? H, s or whatever. But you can't change this thing, right? Because this shows that in which variable you are talking in the polynomial, right? So if in general we take it p because p stands for polynomial, but it is not a fixed thing. You can use any symbol over here but not inside the bracket. All right, so this basic thing is clear, that what is expression, what is polynomial, and what is the standard form of the polynomial, right? Now when we talk about polynomial, we talk about two main important parts, right? First is terms, how many terms are there in the polynomial. Second is what is the degree of the polynomial, right? So first we'll understand that what is number of terms in any polynomial. So number of terms means how many parts are there which are being separated by plus and minus. Again, recall this. The number of terms means how many parts are there which are being separated from the symbol plus and minus, not multiplication, not division, right? You have to count how many parts are there which are being separated by either the sign of plus or the sign of minus. For example, if I talk about the first example, right? Here you can see that there are two signs of plus and how many parts are there? This is complete one part, this is complete one part, and this is also complete one part. So how many number of terms are there? You'll say, ma'am, 3. But if I talk about suppose this, right? Then how many parts are being separated by plus? They are 2 parts, right? So how many number of terms in this example? 2. But you can't segregate this. Pi and x you can't segregate because you have to segregate the parts which are being separated by the sign of plus and minus. So never do this mistake. So we understood how we can count the number of terms in any polynomial. We have also understood coefficient means the part which is being attached to the variable. For example, if I ask that what is the coefficient of x square over here? So you will see that, ma'am, number 1 is attached with the x square. So the coefficient of x square will be 1. Now if I ask what is the coefficient of x, so you can say 7, but the answer will be wrong because you are forgetting the sign right over here. So you have to take or you have to consider the sign whenever you are talking about the coefficient, right? If I ask about the coefficient of x, you can't say plus 7, you have to say ma'am it's minus 7. If I ask the coefficient of x over here, you will say ma'am plus pi, right? But instead of plus pi, you can say plus only pi, right? If I talk about the coefficient of y cube over here, you will say ma'am 7. So I hope these two things are clear. Number of terms, the coefficient. Then when we say what's the degree of the polynomial, you have to count the highest power of the variable, right? So degree means the highest power of the variable which is being occurring in the polynomial. For example, if I talk about here in the first example, the power of x is 1, the power of y is 1, the power of z is also 1. All are variable. So you have to count which variable is having the highest power. So the highest power is 1 over here. But if I talk about in this example, the power of x over here is 2, the power of x here is 1, right? This does not have any variable with this, so you can say this is x raised to the power 0. So if you see, the highest power is here, which is 2. So the degree in this case, this case of polynomial will be 2, right? So degree means the highest power of the variable which is being occurring in that given polynomial. So I hope these 2-3 basic terms are clear. Now let me check the comments because I am coming after so long in the classes. So it is very important that any of my students is facing any problem. If you are facing any kind of problem, or if you want me, ma'am, this is one chapter that we face a lot of problem and we want you to teach it in the upcoming classes, you can also comment down so that in my upcoming classes we can take care of that topic. All right, but for now I can't. Nikhat, thank you so much, and Inaya, thank you so much. Yashika, Latesh, hello everyone. I hope you all are doing good and you all are enjoying all the classes on Buddy Education. But still, if we are, missing out on anything that you want us to support you for that, right, you can comment us so that we can come along with that thing. All right, now let's come to the next topic, which is just wait. All right, which is the types of polynomials. So when you want to categorize the polynomial, you have to use two pillars, right? One is on the basis of the number of terms and the second one is on the basis of degree, right? So first we'll learn how we can categorize the polynomial on the basis of number of terms, right? As for now, we have understood that how we can count the number of terms, right? So if that part is clear, this is very simple to understand. Now they say if you have only one term in the polynomial, then that kind of polynomial will be known as monomial. Means if I am saying this is a monomial, you will conclude that all right ma'am, it is going to have one term. But you have to check when you are stating this thing that it is having one term, right? Then you have to check yourself whether you have simplified that given polynomial or not. Why I am saying this? Suppose if I have given you one example, x minus x by 2. All right, now this is a polynomial, right? Now you can't say ma'am 2 is in the division, so it is not a polynomial. Here when we are saying that an expression is becoming a polynomial, we are only concentrating on the power of the variable, and the power of the variable is whole number certainly here. So this is a polynomial. But if I'll see this, you will say ma'am it is not a polynomial. Why? Because they are having two terms. One term is here, one term is here. But then I'll ask you, have you simplified your polynomial? So the answer is no. Because when the terms are like, you can simplify them. If I'll take the LCM over here, it will be 2x minus x and then the output will be x by 2. Now you tell me how many terms are there? Only one term. So by seeing the first part, if you will make your judgment that because there are two terms, so it is not a monomial, you will go wrong, or you will ended up getting a wrong answer. So make sure when you are stating your answer, how many terms are there, make sure you have simplified them first, right? So after simplification, you can be sure that whether it is having one term, two term, or more than two terms, right? So first we understood that if there are only one term, then we will call it as monomial. If there are two terms, we'll call it as binomial. If there are three terms, we'll call it as trinomial. And if there are more than three terms, we'll call it as polynomial. So one term, monomial; two term, binomial; three terms, trinomial; and if you are having more than three terms, then you will name it as polynomial. So this is how you can categorize polynomial on the basis of the number of terms. Now how we can categorize the types of polynomial on the basis of degree? So for that we have already understood how we define the degree of the polynomial. So suppose if you have the degree as 1, means the highest power of the variable is 1, right? Then you will name it as linear polynomial. If the highest power of the variable is 2, means the degree is 2, you will name it as quadratic. If the degree is 3, you will name it as cubic. If the degree is 4, you will name it as biquadratic, or in general, if the degree is more than 3, you will name it as polynomial, right? So this is understood: degree 1 linear, degree 2 quadratic, degree 3 cubic, right? But again the question is same, that first you have to simplify them. Why? Because just suppose if I have something like this, 7y square divided by y, right? In this case you may say, ma'am, it is not a polynomial. Why? Because you will say, ma'am, here the power is in the negative, because if you will take it, it will be in the negative symbol. So first the mistake can be, you can say, ma'am, this is not a polynomial, but you have to simplify, right? When you will simplify, you will get it as 7y. Now in general it may look that power is 2, power is 1, then it can be the degree will be 2, so it will be quadratic. But after simplification you get to know that it is not quadratic, it is a linear polynomial. So again and again I'm telling you, because this is a very general, very common mistake that we usually do, that we don't simplify and then we state our answer. So make sure that whenever you have to state that which kind of polynomial is, whether on the basis of the number of terms or on the basis of number of degree, right? You make sure you'll simplify it first and then you will conclude your answer. Now here a very important kind of polynomial is being missed, which is constant polynomial, right? Now the constant polynomials are the ones in which the degree is not 1 but the degree is 0. If the degree is 0, means the highest power of variable is 0. Highest power of variable is 0, means the variable is missing, right? Means what? That let's erase it and then make a space and then I'll explain this part. So for now what we are explaining the constant polynomial, and those are the ones in which the degree is 0. Now when I'm saying the degree is 0, means I want to say that the highest power of the variable is 0. Means I can talk about 7 into y raised to the power 0, or I can talk about under root 2 into x raised to the power 0, right? All these example of polynomial are constant polynomial. Or if I want, can I not write it as 7? Yes, of course. I know y raised to the power 0 is 1 itself. So either I write this way or I write this way. Both are absolutely correct. Or I can also write it as under root 2. It means what? Right? It means all the numbers comes in the category of constant polynomial. Because if I write any kind of number, any kind of real number, whether I write 1 by 2, whether I write minus 3 by 4, whether I write pi, any number, right? All these numbers are not having any variable, means the variable's power is, highest power is 0. That's why all the real numbers comes in the category of constant polynomial. But here we have one more catch, that not all numbers fulfill this property. There is one notorious number that does not counted in the category of constant polynomial, and that number is 0. Why? Because you can say, ma'am, 0, we can also write it as 0 into x raised to the power 0, and accordingly we can see that the highest power is 0, and if a polynomial has degree 0, then we name it as constant polynomial. But don't you think you can write 0 as 0 into x raised to the power 1 also? If you solve this, you are going to get 0 only. If you will write 0 into 0 x raised to the power 100, in this case the degree will be 100. So you know 0 is one that number which is not fulfilling this property, right? That's why 0 is not a constant polynomial. 0 is known as zero polynomial, and zero polynomial is the polynomial whose degree is not defined. Why not defined? Because in each case the degree is coming different. In this case you can say, ma'am, degree is 0. In this case you can say, ma'am, degree is 1. In this case you can say, ma'am, degree is 100. Even if I write it 0 into x raised to power 5, in this case the degree is 5. So that's why we say that 0 is one that polynomial whose degree is not defined, and this 0 is itself known as zero polynomial. Now do not get confused in one more term that we are going to learn in some time, because zeros of polynomial and zero polynomial are two different things. Zero polynomial is nothing but the number 0, and its degree is undefined. Its degree is not defined. So I hope till this point everything is clear. Now let me have some water, right, so that I can speak smoothly. All right, just 10 seconds. All right. Now let's move to the next topic, which is, let's do few questions. All right. And then we will move on the values, and then we will move on the zeros. All right. Now the question is that which of the following expression are polynomial in one variable. So first we have to make sure that how many variables are there, and then we have to check whether the given expression is polynomial or not. So both things has to be checked. First, how many variables are there, because they are only asking about the polynomials in one variable, and then we have to check whether the given expression is polynomial or not, right? So in the first example it is very clear that the only variable that is being used is x, right? So certainly it is an expression in one variable. But now the question is, this expression is polynomial or not, right? Now to check that, we have to just check the power of the variable. Here the power of variable is 2. Okay, whole number hai. Now here the power of the variable is 1. So this is also okay. Here the variable is not there, so no problem. So we can see that in this example there is no issue with the power of the variable. All the powers are whole number. That's why yes, it is a polynomial in one variable. So the first example is clear. Now in the second one, in the second example, they have quoted it as y square plus under root 2, right? Y square plus under root 2. All right, it's good. All right, so how many variables are there? Only one variable is there, but is it a polynomial? Of course it is a polynomial, because the variable is y and the power is a whole number. It does not matter that the numbers are having whole numbers as the power or not, right? Because sometimes we may get confused with under root 2, that because 2 is having the power 1 by 2, so this is not the polynomial. But dear students, we have to only check the power of the variable, not the numbers, right? So here the variable is y and the power of it is a whole number. That's why it is also a polynomial in one variable, right? Now let's check the other example, and the example is like this. Okay, now I'll rewrite this example for you. This is 3t raised to the power 1 by 2 plus under root 2 into t. Now here the problem is with the power of the variable. Here you can see that there is one variable, okay, but the power of the variable, here is not a whole number. That's why it is not a polynomial. So I hope through this the definition of polynomial is clear, because if the basic part will not be clear to you, then you will stuck in the complex problem that we will be doing in the upcoming classes, right? That's why this portion I am teaching on a very lighter pace, so that if the basic will be strengthened up, then we will be clear with the complex problem too. All right, now let's come to the next question. And now in this question they are asking about the coefficient of x square, right? In the examples, in the whatever cases they have given. So we have to only, coefficient means what, right? Let's again recall that thing, that coefficient means the number attached with that variable. Again I'm repeating my words. If they are asking about the coefficient, means they are asking about the number. They are asking about the number that is being attached with that variable. Now which variable you are talking about? X square. So let's find x square. So if I see here, the number that is being attached with x square is how much? 1. So here the coefficient will be plus 1, right? Very simple question. Now if you will see the next example, again if you will see this example, here the x square is over here, right? Then the number over here cannot be 1. If you write 1, then you will go wrong, because you have to take care of the sign as well. Here it was plus 1, but here this is minus 1. So if in case if you will write plus 1, in hurry you will go wrong, right? So make sure when you are writing the coefficient, you are also considering the sign which is being there. All right, now let's take one more example. All right, there is no other example, so it's fine. All right, so the next concept is value of the polynomial. Okay, now when you say the value of the polynomial, what do you mean mathematically? Let's understand first the mathematical definition. When you want to find the value of polynomial, you mean to say that if Px is a polynomial in x, right? It can be in x, it can be in y, but for now we are considering a polynomial in x. And if k is any real number, then the value will be obtained, means the value will be obtained by putting x equal to k in px, and that thing will be called as the value of the polynomial at that point x equal to k. Now this definition may seem to be very different, that ma'am, we don't understand what all these things are written, right? Now what is the core meaning is very simple, very simple, right? Whenever you want to find the value of polynomial at any real number, they want to tell you, all you have to do is you have to put that value in place of x, right? Let's understand it better by an example. How? Let's say px is an polynomial as x square minus 4x plus 5, and they want you to find the value of p3, right? p3 means this is the value of k. So here the value of k is 3. Now you know that this is a real number. So they are saying you have to just put this value in place of x, right? So let's put, so in place of wherever I'll see x, I'll put 3 in over there. So I'll put 3. All right, then over here this will be 3 square, then this will be 4 into 3, and then it will be plus 5. Now let's solve this. This is 9 minus 12 plus 5. This will be how much? 9 minus 7, and then your answer means the value of this polynomial at 3 will be equal to 2, right? So I hope whenever they will ask you now, you to find the value of polynomial at any point. Now this x can be any real number. You can find infinite value of this polynomial at infinite number of points, right? Suppose if I give you find p0, so all you have to do, wherever you see x, put the value 0. So this will be 0 square minus 4 into 0 plus 5, means p0 will be 5. Now I may ask you that find p under root 2, right? So you, what you can do, in place of x you can put under root 2, right? So when you will do this, this will be under root 2 square, which is 2. This will be 4 root 2, and then this will be 5. So the final answer will be 7 minus 4 root 2. So they may give you any real number, and all you have to do, you have to just replace your variable with that particular value, and then you have to simplify the way we used to do for the normal calculation. So I hope this part is clear, that how we find the value of any polynomial at any given real number. All right, let's do a question. Now the question is, find the value of the polynomial 5x minus 4x square plus 3 at these particular points, right? One is x equal to 0, second one is x equal to minus 1, and the third one is x equal to 2. Let's do the first part. The second and the third you have to comment me down right away. So I want all of you to answer for the second and third part. First part I am doing. So first you have to write that px is given as 5x minus 4x square plus 3. Now if I want to find p0, right? So I have to replace my x with 0. So this will be 5 into 0. This will be 4 into 0 square, and then this will be plus 3. When I'll solve this, I'll get p0 as 3, right? This is the value of px at the point 0. Now I am waiting for your answer in the chat box. Okay. Okay, quickly send me the answer instead of, having our individual chats. It is better that we'll focus on the study so that we can soon cover up our term 1 syllabus. No matter how many students are watching, it does not matter, right? Every great thing starts with the efforts only. So all you have to do that, okay ma'am, does not matter if I am watching you, I am more than enough, at least I am being benefited by this. You don't need to count how many students are watching, how many people are there. It does not matter, right? So you watch and you get benefited, and if you find that yes ma'am, this is the platform from which teachers are putting lot of effort and they are at least teaching on the pace which is beneficial for us, then tell your friends, recommend your friends, and tell them that yes, there is Monika ma'am who is teaching all the term 1 syllabus at Buddy Education, and let's come together, let's study with her, right? So it does not matter, students, that how many students we are having right now. There will be certainly a day when 1 million or 10 million students will be watching. So do not worry on that part, right? We have to focus on our individual growth. All right. All right. So I hope the second and the third part you will do, and you'll comment me down quickly. Okay. Now the next topic is very, very important, which is zeros of the polynomial. Now from here, everything is very important and everything is interconnected. If you will not understand how to find value, you will not understand how to get the zeros. If you will not understand how to get the zeros, you will not understand the remainder theorem and the factor theorem. So be little concentrated in the class. So when we are saying we have to find the zeros of the polynomial, all we have to do is we have to find that one value of x which will vanish the polynomial. Vanish means what? You have to tell me one that value of that variable. For example, I am talking about a px, right? A polynomial in x. Then if I say you go and find the zeros of this polynomial, then what you have to do? You have to give me one that value of x which will give you the whole output as 0. Means, suppose if I have a polynomial as this. Suppose I have a px like x minus 5, and now I want to find the 0 of this polynomial. Means I want one that value of x which will make the whole output as 0, right? What's that value? Just suppose if I put 5 in place of x, what will happen? Then it will be 5 minus 5 and the whole output will be vanished. Means the whole output will be 0. And whenever you will get this, you can say yes, 5 is the 0. 5 is the 0 of this polynomial, right? So very simple. Whenever I am asking you to find the zeros, it means I am asking you to give me one that value of that variable which will give me the whole output as 0. Now for example, if I have another polynomial in y and this is y square minus 4, right? Then if you will put 2 in place of y, what you will get? 2 square minus 4, which is 4 minus 4. So you will get the output as 0. So you can say yes ma'am, 2 is the 0. Perfect. But what if I put minus 2 in place of y? I will again get the output as 0, because minus 2 square is also 4. 4 minus 4 will give you 0. So it means what? Minus 2 is the 0 or 2 is the 0? Both are the zeros. It all depends on the degree of the polynomial. Suppose if the degree of the polynomial is 1, how many value you will get as 0? 1. If the degree is 2, how many value you will get as zeros? 2. If the degree of the polynomial is 3, suppose it is a cubic polynomial, then how many values you can maximum get as zeros? Will be 3. If the degree is 4, how many maximum values of zeros? Different, right? Distinct value you can get will be 4. So I hope the concept of 0 is clear, that whenever I want to find the zeros of the polynomial, it means I am interested in finding that one value which will give me the net output as 0. So I hope this portion is clear, that what is polynomial, what is a value of polynomial, how we can categorize the polynomial, means the types of polynomial, and then the zeros of polynomial. Now the next topic, right, is, let's do 1-2 question and then we will move to the next topic, which is, I guess, remainder theorem. First we'll understand. Now they are saying verify that whether the given value is the 0 of the adjacent polynomial or not. So all we have to do, we'll try to put this value in the polynomial. If the net output will be 0, we'll say yes, it is a 0. If not, we'll write that it is not a 0, right? Let's put. Now in place of x, what you have to put? X equal to minus 1 by 3. Let's put minus 1 by 3. So in place of 3, I'm just putting minus 1 by 3 and plus 1. Now let's do some calculation. 3 will be cut down, this will be minus 1 plus 1, and the output is going to be 0. So p minus 1 by 3 will be equal to 0, right? And we told you that if the output will come as 0, so yes, you can say yes, this x equal to minus 1 by 3 will be the 0 of this particular polynomial. Now let's do again one more question, and the question is like that px is again a polynomial as 5x minus pi, and we have to check x equal to 4 by 5 is a 0 of this or not. So again we will just replace x by 4 by 5, and then you'll get it as 4 by 5 and then minus pi. Again this 5 will be cancelled out, and then what you'll left with 4 minus pi. Now this output is not equal to 0, so you can now say that ma'am, this x equal to 4 by 5 is not the 0 of the given polynomial. Alright, so I hope these two examples are clear to all of you. Now the next topic is a remainder theorem, but before that I'll take a little break of water, right? It is required. All right. So now I guess there is one student who really, took this very seriously when I said that it does not matter to us that how many students are watching. He's saying, ma'am, I am from SSC board and I want to help the stream. So firstly, I want to say a big thank you to Shlok. But for now, we are running this series for CBSE board, and I guess both boards are quite aligned. But still, if you feel, ma'am, this is one topic that is you are not covering, or this is one chapter that I am very confused in, you can send me in the chat box, and I'll certainly come up with the video on that topic. All right, so do not worry. If there is any topic that you are facing difficulty in, I'll certainly complete that chapter. All right, now let's come to the remainder theorem, a very important theorem, right? First, let's understand its mathematical definition. Now this theorem says that let px be any polynomial. Px means the variable that we are talking about is x in that particular polynomial, and the degree of that polynomial is greater than or equal to 1, right? It means we are not talking about the constant polynomial, because if the polynomial is not going to have the variable, then the remainder theorem will not work over there. Then it will be like the division of the normal numbers, right? So whatever polynomial you are taking, either they are linear or they are means you can say either they are having the degree 1 or greater than 1. This is the first condition in remainder theorem, right? Then if it is so, then let a be any real number. All right, then let's consider any real number. Then px is divided by the linear polynomial x minus a. They are saying if you will take any polynomial px, and if you want to divide it by any linear polynomial x minus a, and if you want to divide it and you want to find the remainder of this, right? And then you want to find the remainder of this, then one procedure is that you will write a polynomial and then you will try to divide it by the long division process. But what if I am not interested in that long division process? Is there any short way which can directly give me the remainder? Yes, definitely. And what's that result? That result says that in that scenario, P of A will give you the remainder of that particular scenario, right? Now P of A means all you have to do, this A value you have to place in the place of X. Now how we can apply this, right? This is the mathematical definition, but this is what it want to say, that if you want to divide your px by x minus a, any linear polynomial, and if you are interested in finding the remainder, instead of going with the long division process, all you have to do that if you want to find the remainder, you can find P of A. P of A means the value of that polynomial at the point A. Now how we can apply this in the question? Now the question is that you have to find the remainder when this is one polynomial in the x, when you will divide this by x plus 1. Okay, so it means this is the linear polynomial. Okay, so first we will write that px is given as x cube plus 3x square plus 3x plus 1, right? This is the polynomial. And by which polynomial I am dividing this? By x plus a, x plus 1. So first I need to compare this with x plus a, right? Then only I'll get the value of a. When you will compare this, what will be the value of a? This will be 1. Now they have told you that if you want to find the remainder in this case, then all you can do, you can find p of a. A means p of 1. And we know how to find the value of any polynomial at any certain point. It means now in place of x, all I have to do is I have to replace the x by 1. Now let's replace this. So I'm going to replace x by 1. So it will be 1 cube plus 3 into 1 square plus 3 into 1 and plus 1. Now this calculation is very simple. It will be 1 plus 3 plus 3 plus 1, 3 and 3, 6, 7 and 8. So what is the remainder? The remainder will be 8, right? Okay. So you can see that by using this beautiful theorem, remainder theorem, we will, we have escaped ourselves from using long division process. Else, if you will, start dividing x plus 1, sorry, this polynomial by x plus 1, you can do it, but it will take a lot of time, right? So remainder theorem actually saves us a lot of time, right? So this is how we can apply the remainder theorem on this kind of question. Again, I'm repeating this because this is the basic, right? Then when we will do complex problem, it is very important that at least you should know the basic process. So first you will write a polynomial, then you will see that whatever linear polynomial is given, you'll compare this with always x plus a, not x minus a. Even if this is x minus 1, you'll not compare this with this, okay? You'll compare, all right, we have done one mistake. We have to compare this with x minus a, because in the theorem you must have seen, right? This will go wrong because if we'll see, get back, it will take a lot of time. We have to not compare this with x plus a, we have to compare this with x minus a. So here this will be minus 1, here this will be minus 1, minus 1, minus 1, minus 1. So this will be minus, and I guess there will be one more change. Let's do this calculation over here. Thank God we have checked it, and that's how, these are the tiny mistake that can be occurred at any time. So we have to always recheck our thing. So we have to compare. This is one thing that it's good that we have done this mistake, else you will do this mistake, right? So x plus 1 will be compared with x minus a. So this will be, of course, when I'll do the comparison, a minus a will be 1. So a will be minus 1. And when you will put in the place of x, this will be how much? Minus 1 plus 3. This will be minus 3. And then this will be plus 1. They will be cancelled out. And this is also cancelled out. So the remainder is 1. So the remainder is, 0, right? So in case, even if in the case, suppose the question would have come that divide this polynomial by x minus 1. Even in that case, you'll compare this with x minus a, and then in this case, you'll get a as 1, right? So you have to make sure no matter the sign is negative or the sign is positive, you will always and always compare this with the negative of it, okay? X minus a. All right, this is one question. Now let's move to the next question. There is one more question. Again, in this question, they are asking about the remainder when this same thing is being divided with x plus pi. So again, we will first compare this with x. Again, we are writing the same thing, x minus a, correct? In that case, if you will compare, then this will be pi, and that is equal to minus a. So the value of a will be minus pi. Now, how we can find the remainder? We know in this scenario, the remainder is nothing but p of a, right? Means we want to find the value of this polynomial at minus pi. Now, if you want to solve this, what you have to do, that in place of x, you will just replace your x with minus pi. Now, let's do it, okay? So this will be minus pi and this will be minus pi cube plus 3 into minus pi square plus 3 into pi plus 1. Alright, let's solve this. This will be minus pi cube, this will be 3 pi square, this will be 3 pi. You know there are no like terms, so you can leave your answer over here, and this is the required remainder in this case. Now there is one common error that we may do in this question, that in place of pi either you can put 22 by 7 or you can put 3.14, but that is not required, because whenever they want you to put the value of pi, they'll mention this in this question, right? They'll tell you that okay, put the value of pi as 22 by 7, or you may put it as 3.14. But as there is nowhere mentioned that you have to use that value, you can skip that thing. So never do this mistake, because if you do so, the calculation will be very lengthy unnecessarily. All right, now let's understand the factor theorem. Now this factor theorem is nothing but a small extension of remainder theorem. First, let's read its mathematical format and then we'll understand it by an example. They are saying if px is a polynomial of degree greater than 1, okay, and a is any real number, right, then x minus a is a factor of px if p of a is 0. They are saying ki if p of a means the remainder, if you will get your remainder as 0, then certainly the thing from which you were dividing, will be the factor of that. Because we know that if I say you that 2 is a factor of 4, how you can decide this? Because when you will divide it, it will be 2 2s are 4, and then you will get your remainder as 0. It means remainder is that powerful tool from which you can deduce this thing, that yes ma'am, if the remainder is 0, then you can say that particular thing will be factor. If not, then you will say ma'am, that particular thing is not the factor of that particular polynomial. And same thing works in the polynomial that we do for the normal, you can say constants, right? Now let's understand this better by a example. They are saying you have to determine whether x plus 1 is a factor or not. So for this, first we will use the remainder theorem. We'll find the remainder. If the remainder is 0, you can say yes, x plus 1 is a factor. If not, you will say x plus 1 is not a factor. Now we know if we want to find the remainder, first we'll compare this with this. You'll get the value of a as minus 1, then the remainder will be p of minus 1. Now we have to check whether this will give the output as 0. If this will give, we will say yes, it is a factor. So now p of minus 1 will be minus 1 cube plus minus 1 square plus minus 1 and plus 1. So this will give you minus 1 plus 1 minus 1 plus 1. They will be cut down, they will be cut down. So the output is certainly 0. So yes, you can say that x plus 1 is a factor of x cube plus x square plus x plus 1. So it means if you want to use factor theorem, first you have to be confident enough with the remainder theorem. And if the remainder theorem is clear, you can find the remainder. If it is 0, you can state yes, it is a factor. If in case this will not come as 0, you can say yes ma'am, this is not a factor. So till for today, this is enough. This is where we are stopping. So today we have understood about polynomial, we have understood about types of polynomial, we have also discussed about value, zeros, remainder and factor theorem. After this, we'll be going for the most crucial part of this chapter, which is identities and factorization. That is one part I have seen many of the students always come up with the problems. I'm sorry. Ma'am, we are not able to factorize. Ma'am, we are not able to understand in which question we have to use which identity. So don't worry, students. Soon in your next class, I'm going to cover up that portion. So stay tuned and tell your friends that yes, there is a channel, Buddy Education, where we are preparing for the term 1, right? And keep on sharing your love, your comments, your problems, your doubts, anything, right? Anything for which we can support you. I'll see you all in my next class. Bye bye. Take care, everyone.